All right, as we continue with polynomials, we've defined polynomials, then we added and subtracted them by combining like terms. We looked at some different ways to multiply using the distributive property, and then some shortcuts, which were FOIL, special rules for squaring, or sum difference products. Now we're going to get ready to do division, but before we can do that, we need to go back and look at a final rule for exponents that we haven't studied. It's called the negative rule, or the negative exponent rule. This one actually sounds a little odd because what it says is if you have a base to a negative power, what that means, it does not affect the sign. What it affects is the position of the base. X to the negative a is 1 over x to the positive a. It's as if it told you to take this base and move it down below a fraction line. And so although it's not very mathematical, what I remind students is that a negative exponent says move me. Move the base across the fraction line. Let me see if I can make this seem to make a little more sense to you. Let's look at an expression. Let's look at x to the second over x to the fifth. Well, let's simplify that, but let's use the quotient rule. The quotient rule says to take x, the base, and the numerator exponent minus the denominator exponent. That will be x to the negative 3. So this expression is the same as x to the negative 3. Now I want to take it and I simply want to reduce this the way I know how to reduce fractions. Let's look at the numerator. It's really x times x. The denominator is x times x times x times x times x. I can reduce this. Common factors, common factors. What does that leave me with? Well, in the numerator, it leaves me with a 1, because every time you divide out a common factor, you're really leaving 1s behind. In the bottom, I have x times x times x, which is x to the third. Now, I want you to take a look at this. This statement is telling me that an expression is equal to x to the negative 3. But that expression is also equal to 1 over x to the positive 3, so these two must be the same. So a negative exponent simply says, move me. If it happens to be a negative exponent in the denominator, suppose I have a over b to the negative 2, then it will take this base and still say move me, and you will end up with a b to the second. It will be over an implied 1 that you won't write. So let's look at using this rule for negative exponents, which says move me. The first one says simplify 6 to the negative 2. Well, negative exponent says move me. It's going to be 1 over 6 to the positive 2. Raise that to the power. That's 1 over 36. And it says to type an integer or a fraction. Okay, next one. 8x to the negative 2. Now you want to be kind of careful. This negative 2 is only affecting the x. If it were to affect that entire product, the product would have to be in parentheses. So this is the only factor that it's saying to move. That means that the 8 is left on the top. X to the now positive 2 is on the bottom. So negative exponent says move that base across the fraction line. It becomes positive. All right, next one. I have the fraction negative 1/5 raised to the negative 4th power. Well, that is going to be, let's use the power rule that says both the top and the bottom are going to be affected by that exponent. And I'm going to just move the negative, if you don't mind, I'm going to let it be with the numerator. So I'm going to rewrite that as negative 1 over 5 to the negative 4th power. It doesn't matter. It's just easier if it's attached to something. So this is raised and this is raised. So it's negative 1 to the negative 4th power, and it's 5 to the negative 4th power. Well, each of them say, move me. That means the 5 is going on top to the positive 4th. The negative 1 is going on bottom to the positive 4th. The 1 didn't change its sign, just the exponent did. Now raise those. 5 to the 4th is going to be, I think it's 625, but let's see. Yes. So that is 625 over negative 1 to the 4th power is 1. Your answer will be simply 625. One other thing you could say about that is anytime you have a fraction raised to a negative power, it is the reciprocal of that fraction, both of them moving, raised to the positive power. But you could do it this way. All right, number 4. I'll give myself just a little bit more room here. I have 4 to the negative 1 plus 8 to the negative 1. Well, 4 to the negative 1, that's going to be 1 over 4. Plus 8 to the negative 1, that's 1 over 8. Each of these has an implied positive 1 exponent that I'm just not writing. To add two fractions together, I have to get a common denominator. The common denominator will be 8. So this is some 8s, and this is some 8s. 4 goes into 8 2 times, and 2 times 1 is 2. 8 goes into 8 1 time, and 1 times 1 is 1. Add those together for 3 8s. If you want to, you could have gone off to the side if you felt more comfortable writing them out like this with your common denominator over here. That's a little bit more of a traditional approach. All right, last one. It has 1 over p to the negative 7th. Remember, negative exponent says, move me across a fraction line, please. That's going to be 1 times p to the positive 7, and you're leaving a 1 down here, but I don't need to write those 1s. 1 times p to the 7th is p to the 7th. I don't write a denominator of 1. So a negative exponent says, move me across the fraction line, my power becomes positive.